Hello there, welcome to the October 2020 paper 1. Here we're looking at question 3. Figure 1 shows a sketch of two curves C1 and C2 with polar coordinates C1 and C2. The region R lies inside C1 and outside C2, which is shown in the shaded figure 1. Show that the area of R is equal to P root 3 minus Q pi, where P and Q are integers to be determined. Right, okay, so what we first need to do here is find the intersection of both of these graphs. So that's the first thing to do then. So find out where these two graphs intersect. So it's going to be 1 plus sine theta equals 3 minus 3 sine theta. Just expand the bracket straight away. Let's put 4 sine theta on this side, putting the right hand side 3 on the left, and then subtract 1 from both sides, so subtract 3 to 2, and then divide by 4, so it's going to be sine theta equals a half, so therefore we get solutions of pi by 6 and 5 pi by 6. Okay, so that's where we're integrating in between. Now it's going to be 5 pi by 6 to pi by 6. Well, actually, the way I'm going to be doing this question here, I think, is actually I'll chop my question in half, work out this section here, and then just double it. So I'm going to do boundaries from pi by 2 to pi by 6, and then just double it. Now, so how are we going to do this bit here? So I think what we'll have to do is we'll have to do inside C1, so we're going to have to work out the area of C1, but then take away this white bit of area here, so take away area 2. So just a reminder of the area integral calculation, it's going to be a half between your two boundaries, alpha and beta, of r squared d theta. So in this case here, we want to now do the area bounded by C1 take away the area bounded by C2. So the integral of this, and actually because I'm going to be working in between pi by 6 to pi by 2 and then double it, I'm actually going to scrap the half because of the doubling process to get the other side, so just you'll see that now. So I'm just going to be working out the integral from pi by 6 to pi by 2 of C1, which is going to be, and it's going to be C1 squared because the integral formula is for r to be squared, so it's going to be 1 plus sine theta squared, and then it's going to be d theta minus the boundary from pi by 6 to pi by 2 of C2, which is 3, so 3 gets squared as well, that's going to be 9, and then it's going to be 1 minus sine theta d theta. Now what you could do is you could work these both these areas out separately, or because actually they have the same boundaries on the integral, you could actually combine them together in one big integral. So what I'm now going to be working with is the integral from pi by 6 to pi by 2, and then I'm going to combine these two integrals here together. So I'm going to expand the brackets as well, so it's going to be 1 plus sine theta, 2 sine theta plus sine squared theta, and then minus 9 plus 18 sine theta, and then plus 9 sine squared theta. In fact, no, it's a minus, isn't it? Because the double negative will expand from this, but then there'll be a minus at the front, so it's minus 9 sine squared theta d theta. Okay, so this is what we're going to be simplifying together then. So it's going to be 1 and minus 9, so that'll be minus 8. Then it will be 2 and 18, so that would be 20 sine theta, and then it would be 1 sine squared theta and minus 9 sine squared theta, so that would be minus 8 sine squared theta. Okay, so let's just move on to the next page to do that then. So it's going to be the integral from pi by 6 to pi by 2 of minus 8 plus 20 sine theta minus 8 sine squared theta d theta. Just check. Yes, good. Right, okay, the first thing we need to sort out then is this 8 sine squared theta. Now what you have to recall is that this is going to be a double angle formulae rearrangement. So remember, for sine squared, to integrate sine squared, you use the double angle formula for cos 2 theta. This is equal to 1 minus 2 sine squared theta. Now if I want 8, I'm now actually going to times this identity by 4. That would seem a sensible thing to do. And then subtract this 4 onto the other side, so 4 cos 2 theta minus 4 is equal to minus 8 sine squared theta. So now I'm going to replace this with the minus 8 sine squared theta in my integral. So now it's going to be the integral between pi by 2 to pi by 6 of minus 8, but then minus another 4, that would be minus 12, plus 20 sine theta, and then it's going to be plus 4 cos 2 theta d theta. Okay, so now we're ready to integrate, so it's going to be minus 12 theta plus sine will integrate to minus cos theta, and then this one here is going to be plus 2 sine 2 theta between the boundaries of pi by 2 to pi by 6. Okay, so what I like to do now is I like to work out each of these individually. So now the first part is going to be minus 6 pi, and then it's going to be minus 20 times cos pi by 2. Cos pi by 2 is 0, and sine of pi is also 0. So that would just close the brackets there. And then it's going to be minus, open brackets. When you put pi by 6 in here, you're going to get minus 2 pi. Now let's grab the calculator now. It's going to be minus 20 cos brackets pi by 6. So that would be minus 10 root 3. And then the second part is going to be plus 2 sine 2 times pi by 6. Could just do pi by 3. And that would be root 3. Close brackets. And now we're going to open everything up and simplify our final answer. So it's going to be minus 6 pi plus 2 pi. So that would be minus 4 pi. And then it's going to be minus, and then this bit here is simplified to be minus 9 root 3, but then it's another minus on the front there, so it would be 9 root 3 on the plus there. So there we are, that's the answer for this question there. So the answer is 9 root 3 minus 4 pi. And there we are, that's the answer for this question here. So question 3 is 9 root 3 minus 4 pi, with 9 marks in total for that one, so a bit of integration there. Let's now move on to question 4.